Hello everyone, welcome to Business Analytics Programming. This is week 14. We have pretty much finished all the core Python programming related knowledge so far, and there's one piece left, which is actually reading from a file or writing your data to an external file. Python can read information from an external file or write information to an external file. By reading and writing to external file, Python can quickly analyze lots of data, store useful user-generated data, and make programming more relevant. First of all, codes need to know where the file is located to be read or write. It is determined by file path and file name. For file path, there is a relative path, which is relative to where your Python code is stored, and an absolute path, which is given the full file path of all the details. Once you determine the file path, just add the file name at the end, and it is a unique identifier for the file at your local computer. For example, this is how I define the path and the file name. Please note, you need to use / to connect path and file name in Windows system. So typically in Windows system, it is using the /, but in Python, make sure you're using the /. And if you do not use the /, you probably have some error when you are trying to read or write with files. And once we know where the files are, then how can we read from a file? Here is a very simple example. First, we define the absolute file path and the name, and store that piece of information into a variable, which is called file_name_1. And to read in a file, we need to define a file object. To define a file object, we actually use with, the keyword to ensure file is available. The file object will be available in the indented code below. And the open is a function to open a specific file, and it has one of the argument, which is the file name, including the path, basically which file you would like to open. And it has another argument, the second argument, which either R for read, W for write, or A for append. And the default is R. Basically, if you do not specify the second argument, then it's going to be only read the file and you cannot write the file. And then follow that by S, and this one here, my_file, is a name, that's a variable name, and it is actually define the file object. And then you can use the file object in the indented area after this line. Please note there's a semicolon at the bottom, at the end of the line as well. And once we actually define the first line, basically you create a file object. It actually connects with the file that is defined by the file name. And once you define the file object, you can actually read. So read is one of the methods associated with a file object that is actually read the entire file and assign the content to a variable on the left of the equal sign, which can be used later. In this case, we use the content, which is a variable which contains the content of the entire file we actually want to print out. In this particular example, there are only 3 lines, which is the digit in the pi_digits.txt file, and it's basically reading the file into the memory in Python, and then I print it out. So this is actually even very simple, but it shows the logics how you're going to read a file. In summary, first you define the path and the username in the file name, and then you use the with open file name as a file object syntax. And then there will be indentation, and within the indentation the file will be opened for you to do any operation such as read. And then once you read all the information into a variable, you can deal with the variable. And then once the indentation is gone, basically the file will be closed. Now let's look at another example. In this example, we use the relative path, still the same file, but it only contains the file name because my Python code and my external file are in the same folder. In this particular example, we actually read the file line by line. So the readLine method is different from the read method. The read method is going to read everything, but the readLine method is going to read actually each and every line. It assigns each line to an element of a list. So the lines become a list, which each element contains one line of the data, that one line in your external file. So basically, if we print out, we can see there are three different elements in this list. And please remember, there's only one line in the indentation, so the file is only actually read within that one line indentation, and the file will be closed once the indentation is gone. But anything actually is created within as a variable like lines can be used outside the indentation, and we can print those out. And now the lines actually contains three elements. We want to actually combine those elements together to make it a very long string. To do that is actually we're going to use what we learned in the past. We first define an empty string, and we loop through the elements and paste them together. In this particular case, we need to remove any space as well as the new line characters from those elements by using the stripped method. And then you can print out what is the combined all three lines character and how long is that character. And here is another fine example, that is pi with 1 million digits. It is a pretty large file, but you can actually go through the details and find out how we can very similarly do what we have do with 3 lines. You can deal with file with many lines. Okay, we finished how to read a file, and now let's go to the next step of how to write your data, your text into an external file. To write content into a file, we need to first open the file similar to reading a file using the with keywords and the open function. But the second argument with the open function will be a W, which is going to write to a new file, and if this file exists, and then it's going to be replaced. Or we can use the A option, which means we're going to append the new content into an existing file. Please remember, Python can only write strings into text file by using the with open as logic. So remember to use str functions to convert any numerical content into string before write it into a file. Here is one example. In this particular example, I first define the file name that I want the data to write to, which is actually my output.txt. I'm using the relative path, and here is a variable contains my file name. And then I'm using the with open function. In this open function, as I mentioned earlier, there are two arguments. The first one is the variable that contains the file name and the file path and the file name. The second one here is actually W, which means I'm going to write the content into this file name. So if there is no such file with this name, a new file will be created. But if there's an existing file with W, it's going to replace the existing file with whatever we're going to return to it. So that's actually something you need to keep in mind. If you do have a file exist, you use the W, it's going to overwrite it. It's going to replace everything that's already there. But if you're using A, as this example shows, it's going to append to the existing file. So it's not going to overwrite anything there. So as my file, which basically my file is a file object that I can use later within the indented code block. So here I'm using the write method followed by my file, which is a file object. It's going to write anything. It can be a variable, it can be a string into the file. In this particular one, it is string. And please remember to add in the \n at the end, which basically is going to start a new line. Otherwise, it's going to actually write to the same line. Then that's how you're going to actually create a brand new file to write some information into that file. And then if the file is already existing, then we want to add in some new stuff. We're going to open the file and use the second argument as append. By doing that, we can write the third line of code of information, the fourth line of information. So this is basically how we're going to write some information to an external file. And in this particular example, you can try to a few kind of wrong ways to mess up with the code. For example, different W, A, and R. And also, if you remove the new line character, you're going to see something that is not what you expect to see. So you can mess up a little bit to learn more about those options. Okay, now let's introduce another concept which is called exceptions. Exceptions are special Python objects that manage error during the code is running. Whenever an error occurs, it will create an exception object. If you do not write specific code to deal with exceptions, the program will stop whenever there's an error. We have already seen this information in the past. If there's a bug in your code and you just cannot finish running your entire code, whenever there's an error, it will stop. However, sometimes we want the program to run continuously even if there is an error, and this is the topic of handling exceptions. There is exception, but you can actually handle this exception such that your program is not going to stop, but it's going to continue. Before we go to the detail, let's see what is exception. Okay, for example, we're using print 5 divided by 0, and we know 0 cannot appear as a division here, so Python is going to stop running because there's an error. It's actually going to tell you what's the error. Basically, it tells you is a zero division error because the division by 0. And so the program, whenever the program sees this, is going to stop. So this is a typical error when you divide a number by 0. The program will stop once it reaches this line of code. And zero division error is the exception. And there's other common errors or exceptions. For example, if the code requests to read from a file, but the file does not exist, then it's going to give you a file not found error. There's another common error. If the code accepts a numerical character, but the input contains other characters, then it's going to be a value error. For example, the int b21, oh, I forget there's another quotation mark, will result a value error here. Sometimes we want the program to continue to run when there is an exception. Why is like that? For example, in the credit card application project, the user may enter their credit score, such as 32 BC, which cannot be converted into an integer. So we do not want the program to crash. We just want give the user a second chance to ask them to enter the right information. So that is one example that you do not want your program to crash, to stop, but you want to continue run and ask the user to provide the right information. And this is actually one example of exception, dealing with exceptions. In Python, it's actually very easy to deal with exceptions. To deal with exceptions, we can use the try, except, else block. So basically, we first put the code we want to test in the try block. So here is a very simple example. We want to try this kind of lines of code. We're going to actually use the try, and we put any code we want to try into that block. Remember to indent. And then we put the exception that we want to handle in the exception block. Okay, there's an exception, zero division error. So we're trying to handle with zero division error. So we're going to match whether the exception is going to be zero division error. If it is actually zero division error, then we're going to add some actions if the exception indeed happens. So the action here is we're going to print you cannot divide by 0. So we're going to print out this message to the user if the 0 is actually used in the division. And if the exception doesn't happen, then which is equivalent to say there's no error happens, we're going to put the actions in the else code block. And also remember to look at the indentation here. And the whole example looks like that. Okay, in this particular example, we first ask a user to input two numbers, and then we're going to divide those two numbers, as well as if the user enter Q, whenever during the program is going to quit. Okay, so while true is always true, and then it's going to run this block. First number, input first number, which basically is going to read from the keyboard, and then it's going to read to check whether the first number is actually Q. If it's Q, it's going to break, which means it's going to quit the program from the code block. Second number is actually asking for the second number. It's going to check whether it's Q or not. If both numbers are not Q, then they're going to actually find out the division between those two numbers. But we want to try to catch the zero division error. So instead of run this line of code directly, we use the try except else code block. First, we actually put in, we're using the try keywords and the column here, and remember to indent. Then we're going to actually create the answer is first convert the character into integer and then divide those two numbers. If there's an exception of zero division error, then we're going to print what you cannot divide by zero message. Else, which means if there's no zero division error, then we're going to print out what is the answer. And you can actually have multiple exceptions. You can catch all those exceptions one by one. For example, the user may enter anything that like ABC as the input number. It is not equal to Q, and you cannot convert ABC into a particular numerical number. And then that's another exception, which is actually the value error exception. You can add in a value error exception as well. Then your program becomes more robust, because no matter what kind of information you input, the code is not going to break. It's only going to quit when you actually type in Q. So this is one example of how we're going to deal with exceptions. And you can think about it in the credit card project you have already done so far. The user may input anything like a negative credit score, or input something as a character like ABC or 822. So you need to consider in your credit score project how you can make it more robust by actually dealing with exceptions. Okay, now let's reach the last part for this week, storing data. We learned just a moment ago we can use the file's read and write method to actually read or write text files using strings. We can store numbers into strings and read strings, then convert it to number. However, when there are complicated data structures such as list and dictionary, we need a better approach to read and write data. Luckily, Python can easily read and write JSON data format, which are widely used among different programs to share data. JSON, which is JavaScript's object notation, which is basically a description of how the data is organized. It can deal with much more complicated structures. In Python, once we import JSON, then we can use JSON.dump and JSON.load method to write and read JSON format data. It is very convenient because the data now can be shared with other programming language easily, and the data can be very complicated, like a list or dictionary. This is one example of write data using JSON.dump, basically the dump method for JSON object. First, we import JSON, and then we create a dictionary with 4 key value pairs. So this is a complicated structure. It is a dictionary. And then now we define the file name that we want to write the data to, which is file_output.json. Very similarly, we need to create a file object using with open file name with the argument of w. We're trying to write something into that file as my file. So my file become my file object. the JSON.dump method, actually there are two arguments. The first one is basically what's the data you want to write to a JSON format. And the second argument is basically the file object, which actually is created. What is the name of the file and what you want to read or write, etc. So after we call this JSON.dump method, we're going to save all the information in fav_lang into the file _output.json file with the JSON format. Once we have an output file using JSON format, we can read it in. For example, we just created this file _output.json file, so it has a dictionary with 4 key value pairs. Now let's read it back again. Okay, first we define the file that we want to read in, and then we create the file object. In this particular case, we're using R. Basically, we're reading something from the file, and then you can easily use the json.load method to read in the file and assign the content of the file to a variable on the left of the equal sign, which is read_input. Okay, after we run this, basically the read_input is going to be, as we expected, it's a dictionary with 4 key value pair. And remember, in dictionary, the order of the key value pair doesn't matter. So even though we have exactly 4 key value pairs, but the order are no longer the same as what we put in here. But in dictionary, the order doesn't matter. So this is one easy way to quickly read and write the data in JSON format. Okay, that is the homework part. First, read chapter 10 of the textbook. Second, type and run all the Python code in chapter 10. And because in this particular homework, we need to read or write files like the pi_digit and the pi_million digit files, etc. For those files, actually, you can download from this link. This is from the textbook's official homepage. Within that, once you download this zip file, you can first unzip the file and then go to the chapter_10 directory and copy the needed files into the folder where your Python code are stored. And for 523 student, there's an additional step. Basically at page 199 of the textbook, try it yourself 10-4 and finish that task. Okay, that's all for today. See you next time.